Hello, great scientists of the fifth grade. You should have your science journals open this afternoon, and your pencil should be in your hand. And we're going to write the Monday, August the 31st on the top right hand corner of our notebooks at the computer center, excuse me. And today's objective is I can explain the relationship between gravity, mass, and air resistance. Hold on one moment, students. Okay, bowling ball, golf, and golf ball. I want you guys to take some notes, jot some things down that is going on inside of this experiment. Ready? All right, go. Whoa, some malfunctions. Okay, here we go.
So, Galileo at the Leaning Tower of Pisa in the 1600s, when people were still kind of believing that the church was all knowledge. We've talked about this in history and science, right? Started to find independent thinking and say, I'm going to test things like a scientist. For the first time, people started using independent thought and testing for themselves what would happen, right? And so we could believe what Galileo wrote about, the law of falling bodies, or we could see if it's true for ourselves. So instead of reading about it in the textbook, let's find out golf ball or bowling ball, which is going to hit the ground first. So let's get a little 5-second countdown. And right, you might do. Yeah. Okay. 5, 4, 3, 2, 1. Ready?
Pencils are up, hard at work. Write in your notebook every time you see the picture. And you just saw the picture. I want you to actually reflect on what's happening. What happened when the bowling ball and golf ball were dropped at the same time? Stop and jot. You can pause the video as you need be. Hammer versus feather. Okay, guys. Let's put our thinking caps on. We're going into another video. Make sure you take notes. All right, let's go.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
Beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb.
Okay, again, students, write in a notebook every time you see the picture. Same thing as a stop and jot. What happened when the feather and rock were dropped with air in the tube? And Mr. Goodwin could change that, but we know what I was trying to say. What happened when the feather and rock were dropped with air in the tube or air in tube? You can pause your video right now and take critical thinking notes. All right, Mr. Goodwin's going to go ahead and go on.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
Beautiful picture, Dave.
well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb.
Okay, students, one more video. Ready? Let's go.
This is a science show on UR. Alright.
So gravity is a force and it's produced by anything which has mass. So in our case the Earth pulls us down so we stay on the ground. That's why we don't float off into space. But by the same respects, even I produce gravity. I know it's hard to believe, but it's only a little bit. Even the walls around us all produce gravity because they contain mass. And the biggest mass in the solar system, the Sun, pulls us in. That's why we orbit around. And today we're going to show you an experiment with what happens when you play with gravity. Our everyday experiences tells us that different objects fall to the Earth differently. For example, a paper aeroplane falls to the ground quite slowly, and a bottle full of water falls quite fast. Oh, that's a near miss. But what happens when you take air resistance out of the equation? When NASA went to the moon, one of the experiments they performed involved taking two unusual objects with them. These were a feather and a hammer. Okay, they're not quite, but hopefully you'll get what we mean. What they showed was that objects fell at the same rate regardless of how heavy or big they were, which seems contradictory here on Earth, but we're going to show you this anyway. So naturally, with our student budget, we can't afford to go to the moon, but we've delved deep into the physics department and we found this experiment. In the bottom of the tube here is a feather and a hammer, and when there's air inside the tube, have a guess what wins? The hammer, of course. In that last experiment, the hammer won by a country mile. So what we're going to do now is try something slightly different. We're going to remove all the air from the tube inside to give us more moon-like conditions. Welcome to space. Okay, so we shall now try the experiment again. So last time the hammer won, hopefully things will be slightly different this time.